Değerli katılımcılar, kıymetli meslektaşlarım, ismim Kadir Kara. 1991 yılında iş hayatına başladığım Ekinciler Demir ve Çelik'te hattane müdürü olarak çalışmaktayım. Aynı zamanda METEM Yürütme Kurulu ve ISS Uluslararası Hatta Sempozyumunda Yürütme Kurulu Başkanlığı'nı yapıyorum. Bildiğiniz gibi 2020 Eylül ayındaki Hatta Sempozyumunu pandemi nedeniyle 20 Mayıs 2021 tarihine ertelemiştik. Önümüzde yaklaşık bir ay gibi bir zamanımız var. Ancak malumunuz şu an için Türkiye'de vaka sayıları hiç de iyi gitmiyor. Önümüzdeki günlerde bu konuyla ilgili sizleri bilgilendireceğiz. Evet, sizlere Türkiye'nin en güneyinden, her sokağında çeliğin konuşulduğu güzel şehrimiz İskenderun'dan sesleniyorum. Yoğun bir günün ardından sempozyumun son oturumundayız. Dijital bir etkinlikte dijitalleşme ve Endüstri 4.0 konuşmadan olmaz tabii ki. Demir çelik sektörü, inşaat, altyapı, otomotiv, beyaz eşya, makine sanayi, savunma, ulaştırma, ev eşyası gibi pek çok sektöre girdi sağlayarak lokomotif sektör olma özelliğine sahiptir. Dünyada Endüstri 4.0 ile birlikte ticaret, üretim ve tüketim yeniden dizayn edilmektedir. Endüstri 4.0'a ayak uyduran ve geçen şirketler gelecekte ayakta kalacak ve rekabet avantajı sağlayacaktır. İşte bu sebeple sempozyumumuzun bu son bölümünde demir çelik sektöründeki dijitalleşme ve Endüstri 4.0'ı konuşacağız. Bu oturumda da birbirinden kıymetli 5 sunumumuz olacaktır. Küçük bir hatırlatma yapmak istiyorum. Ekranlarınıza dijitalleşme ve Endüstri 4.0 ile ilgili 3 sorulu bir mini anketimiz gelecektir. Bunu oturum boyunca anketimize katılırsanız bizi çok mutlu edersiniz. Ekranın alttaki ikona tıklayarak anketimize katılabilirsiniz. Evet, ben sözü fazla uzatmadan ilk sunum başlığımız Öğrenen Metal Tesisi SMS Digital Türk Metal Cemiyeti ile buluşuyor. Konu başlıklı sunumu SMS Digital'den Sayın Bernhard Stinken ve Can Yalçın yapacaklar. Sayın Bernhard Stinken, meteoroloji mühendisi, 2017-18 yıllarında SMS Grup'ta çalıştıktan sonra 2018 yılından beri de SMS Digital'de CEO olarak çalışmaktadır. Sayın Can Yalçın, Karlsruher Teknoloji Enstitüsü'nde üretim planlama master'ı yaptı. 2 yıl Cevher Grup'ta akıllı fabrikalar global proje müdürü olarak çalıştı. 2019 yılından beri de SMS Digital firmasında global satış müdürü olarak çalışmaktadır. Evet, oturumda başlayabiliriz. Söz sizlerde Sayın Bernhard Stinken ve Can Yalçın. Buyurun.
Hello, very warm welcome from my side. I hope you can now see me and hear me clearly.
Yes, that's okay. That's good.
Hello everybody from my side.
Okay.
Öncelikle merhaba dilerim. SMS Grup olarak bu etkinlikte sizinle buluşmaktan dolayı mutluluğumuzu istiyor. Etkinliği düzenleyen herkese çok teşekkür ederiz ve katılanları da selamlarız. Bugün 150 yıllık geçmişe sahip SMS Grup'un dijital çözümleriyle ilgili sizinle karşınızda olacağız. Birlikte metalurji sektörünün geleceğine doğru sizinle The Learning Metal Plant konulu sunumumuzu paylaşacağız. With that, I would also like to switch to English. My name is Can Yalçın. I'm a Global Sales Manager at SMS Digital. Today, I am together with our CEO, Bernhard Stinken, and we will give you insights on our vision, The Learning Metal Plant. Bernhard, can you go further next page, please? So shortly, who we are. SMS Digital at one glance. We were founded in April 2016 and are coming with the roots from the SMS Group. Currently having more than 350 digital experts on site and we are combining our digital expertise with our 150 years of metallurgical know-how. Our presence is currently worldwide. We are given in Germany, India, China, USA, and Brazil with entities and plenty of international partnership networks. What is our tasks? We are focusing on digital products and applications, software development solutions, which also include data analytics, artificial intelligence, and machine learning. Furthermore, we are coming with platform and cloud services, and also consulting with focus on digital transformation, where we are also combining our metallurgical know-how and our lean expertise. Our success is not just related to us. Of course, we are covering several specialists from our group. I think partly you have already had business also with these companies. We are a full-line domain know-how provider, and we are already coming with hundreds of digital product services and expertise. In the next slide, I would like to give you an insight of our vision, the dark factory. Bernhard, if you can move on. I would like to show you a short video here about our vision. This vision is not that far, and after the video, Mr. Bernhard Denken will give you further insight on the details. Anna, thank you. The stage is yours.
Thank you very much, Jan, and very warm welcome from my side. As Jan already mentioned, I'm now since 3 years responsible for the digital business of the SMS Group. And our challenge and our vision is big, and we are really targeting to transform the metals industry and to push efficiency to the next level. Nevertheless, everything is based on our know-how and our processes and the equipment which we, let's say, are supplying, but also we are working, of course, brownfield with third-party equipment, because at the end, it's about the end-to-end optimization of the production in the metals industry. And with our Learning Metals plant, the basis is, of course, a fully integrated value chain. So for example, here for flat products, what you can see on the right side below, so starting from the blast furnace down to the finishing lines with the level 1 and level 2 systems on site. Same applies to the long products. So at the end, this is the basis. But the basis, this is where we are starting with. And what we are doing is because we want to, and we are optimizing the processes end to end. And we are merging the information in our data factory from all processes, from all different types of data sources into one unique data source of truth, where we are turning information, data into information and information into value. But especially since there's a large installed base, and we clearly know, and this is, let's say, the major question which we are always, let's say, getting asked, where to start. And we have a very clear approach. So we are assessing the equipment, and in most cases, it makes sense to start with the assets. Because at the end, or at the beginning, it's always about uptime. So predictability of the machines. The clear KPI which needs to be optimized is machine availability and stability of the process. And we have an integrated solution which is not only optimizing the plant availability, which is also stabilizing the process. Because if you have the machine available and a stable process, your plant is ready to produce the right quality. And also in terms of quality, we have an end-to-end solution which is holistically optimizing the quality. And this is also where I will today deep dive in. But nevertheless, we know, of course, production, especially in the metals industry, is not stable over weeks, days, months. There's always some uncertainty. And this is also why we have in our learning metal plants our own production planning system. And our suite is fully integrated. So we are merging asset optimization with quality functionalities and production planning. And we always knew there are four main drivers for industrial digitalization in the metals industry. And the fourth one is energy management. This is why we have invested in a company in Brazil, 200 experts only focusing on predictive energy management. The company is, as I mentioned, called VETA, and they have a market-proven solution for predictive energy management, which is called Viridis. And all our solutions are fully integrated based on one suite, and they are interconnected. So the different industrial digitalization drivers and systems are exchanging information and optimizing the operation. But overall, of course, at the end, to find the clear KPI, and the KPI is to produce the products in time, in quality, in budget, so at lowest cost. The overall solution area is very complex, and this is where we're applying our learning algorithms. So let me give you a further insight what we are really doing. So here down below, you can see the production chain, and there's of course process optimization. So for example, especially when we talk about processes, they are already quite far to the physical optimum. There's not much way to improve. But if you are taking it to a level more up, so to really not only optimize the process, so to optimize the entire production in terms of the four value drivers, asset, energy, quality, and planning, you're already stepping one step further. But we are combining our expertises and our solution and enlarging our portfolio to an holistically end-to-end AI-fueled production optimization for the four value drivers of industrial digitalization. And we have a toolbox, and I prefer the name toolbox because we clearly know that you, especially your operators, they have so much know-how about your equipment. This is why we are providing tools. And our tools, they are not empty software shells. So we are implementing our expertise into the tools. So this turns really the tools into solutions. And then you can work with our solutions, enhance it with your knowledge. And for example, for the predictive asset health, I will exemplary-wise show 3 tools. So we have our own condition monitoring system, which is generating new data, which is already enhanced, let's say, or equipped with prediction functionalities. We have our process condition analyzer, which is holistically rule-based, assessing the health of your equipment. So the system clearly provides you with the information, is my entire hot strip mill in the right condition, for example, to produce now a 1.0 millimeter thin strip. And then we have our asset optimization AI suite, which is pushing and providing you with prediction functionalities and which is enabling you to go to prescriptive maintenance. But also we are very active in the field of product quality. So the basis there is our quality execution system, where I will also deep dive in today, which is, let's say, based on a huge reference basis. But also there we have prevention systems, because prediction is by far not enough. It's about prevention. It's about cracks prevention. It's about the optimization of the mechanical properties, because at the end, a prediction doesn't help you to get more efficient. It's just predicting something. So the countermeasures are this what really counts. Then we have our production planning system where we are covering the full scope. So from MES to BI to warehouse management systems, and our predictive energy management suite. So the Viridis energy platform with also more than 30 additional applications on top of it. Applications like Energy Shaper, Golden Batch Optimizer, or we are even ready to support you to generate CO2 certificates on product level. I'm not talking about averages, I'm really talking about product level CO2 certificates. So let's deep dive a little bit into what predictive quality is really about. So here you can see our framework. So the basis is, one more time, the production chain. So starting from steel making down to the final product. And we are merging the entire information in our data factory. And this information is turned, let's say, or this data is turned into information via our quality execution system. So we are helping and supporting you to assess your quality, to release your coils without human impact. And we have an optimization layer. So we are providing you with a digital twin for simulations and to make you ready for predictions. And we have prediction models in the 3 dimensions, in surface, geometry, and properties. And based on these predictions, we are supporting you with our methodological expertise to come up with actionable items, because this is really what is important. So prevention, it's not about prediction. It's about preventing a failure to occur. And we are doing it live with direct feedback, closed loop. So this really helps you to optimize your product quality, to prevent cracks or failures to occur. But let me deep dive a little bit into our quality execution system. So here you can see it's green, and actually the nice thing about our software is it's flexible. So every operator can create his own dashboards. For example, at one reference, we have 200 people working with the software, which are creating their own dashboards. So everything based on our solution. And there are rules inside. So based on our know-how, which we can implement into the software, based on your know-how, we are evaluating the quality. So it's a rule-based system, but also enhanced with prediction functionality. So there's a data correlator inside, which makes it more or less to a self-learning system by correlating data. And in these dashboards, you have all important data from the quality monitoring available, and this within seconds. So you can click on one coil, you have all upstream, downstream data available, because we are providing and supporting you to build up a full-blown genealogy from melt down to the finished products. So actually, at the end, it's a full-blown digital twin of your product, which you can even sell, especially when you're providing the market with high value-added products. So you can show the full transparency, because we are not only implementing and merging the quality information, we are also adding the process parameters. So you have all information available in one system, where your operators can work with, where your technicians can work with. And they don't have to look for data, because the data from all your production processes is available within seconds. And we have already, this number is even outdated, so we now have already 43 references since we closed this week actually, 2 more deals on our quality system, because it's by far the market leader in terms of quality execution systems. And let me quickly also show you some numbers. So one key European steel maker, where we have connected the system to 20 lines, so 5 million tons of production, he had the target to save $10 million per year. And now he already doubled this target. So this system really helps you to make your production, your quality better, more efficient, and more sustainable and more reliable to your customers. But how are we achieving these tremendous results? So let me show you here an example of a PLTCM where we are turning the data into information. And now I will show you how you can turn the information into value. So when you have, let's say, your hot strip, or when you want to start your PLTCM process, you have before production all relevant quality data available as a preview to the PLTCM. And in this case, you can already see, oh, there are some parameters not in line with the customer specification. So this is shown here. And now you can see the benefit of the genealogy and the length time correlation. So this is an example of a hot strip mill, as I mentioned, of a hot strip. So you can see after 450 meters, you have crowns on your coil, which is here represented by the red curve. So it's not in the customer specification anymore. Same applies to wedges. So you have small wedges between 270 meters and 400 meters, and starting again to build up wedges between 500 and 550 meters. So it's not in compliance with the customer specification. And now there are several options, and our quality execution system is with a reallocation system enhanced. So we are assessing all planned coils, and the system can reallocate the coils to an alternative customer order. But also, let's say, the operator can prepare for manual actions because he has the information available. There are crowns on the strip and wedges. So maybe it makes sense to adapt the process parameters. And this can be done manually, but also we are now, let's say, targeting, of course, not manual operations. We are targeting closed loop AI optimization. And this is shown here. So now I will really deep dive into 4 use cases. So this is the first use case where not the operator is taking the actions. Here, the closed loop AI is taking the actions. So what are we doing? We are one more time merging the upstream information process data, so from the cold rolling, pickling, hot rolling mill, as well as the from the import device, so the information from the post-treatment area, as well as the information from the line automation in our SMS data factory. And then we have annealing data-driven models. So where we are using and calculating based on advanced analytics and AI, optimized annealing curves based on the pre-processes data. And these optimized annealing curves are sent to the mathematical model. So it's a closed loop system for automatic calculation and control of the furnace parameters according to the given annealing curve. So closed loop optimization. So not the operator is taking the actions. Here, the annealing data-driven model is predicting optimized annealing curves, and the mathematical model is fully interconnected with the line automation and is changing the PDI settings. And the benefit is tremendous. These are actually numbers provided by the customers which are using our solutions. So in one case, we have achieved 25 to 50% less variability of mechanical properties. In that case, yield, tensile strength, and elongation. And in case of advanced high-strength steels, we achieved a reduction of non-prime coils from 8% to 3%. So this is a very tremendous business impact, overall $2 million saving per annum, just based on one use case. A second use case, everyone knows cracks or failures in the casting machine. This is very painful because longitudinal facial cracks, for example, they clearly result in scrapping or at least downgrading. So we have an application developed and implemented which is preventing cracks and different types of cracks. So longitudinal facial cracks, slivers, laminations, corner cracks, edge cracks, as well as breakouts in one application. But what are we doing? We are assessing the risk in real time due to cracks in casting by cracks prediction. No, we are predicting that something is failing or going wrong. We are predicting breakouts, but then we have automated root cause analytics, real-time countermeasures, and this is really what counts. The countermeasures, this is what turns a prediction into a prevention system. So 3-level methodological expert suggestions. And the benefit is 30% lower cost to poor quality, and our solution can be applied to one failure mechanism like longitudinal facial cracks, or can be applied holistically to several failure mechanisms in parallel. And our solution can be provided on cloud or as an on-edge solution. And we are offering performance-based solutions or performance-based payment models, as well as subscription-based pricing models. And here's a very nice use case, actually not even a use case, it's a very large-scale project where we have connected our systems to 4 casting machines, 1 hot strip mill, and the challenge was to reduce defects, for example, inclusion cracks, like longitudinal facial cracks, corner cracks. And we have implemented, or the target was as a challenge to reduce cost for diverts and retreats. And the solution was, we implemented our data factory to gather and connect process and product data. We implemented our QAS system for the rule-based evaluation and our product quality AI to predict quality defects and to recommend countermeasures. And the financial benefit of this project was 30% lower cost to poor quality. And the nice thing is we closed a 5-year software as a service contract, so a fully off-balance sheet financing for the customer. And another use case, so our tuning kit for BOF operations in terms of BOF slopping prevention. So there we already, let's say, had in the past several installations for detection and prediction of slopping. And this was now enhanced and further developed to prevention. And what are we doing? We are implementing visual and audio detection to the BOF as a, let's say, a tuning package, which can also be applied brownfield to all BOFs which are in the field. And then we are merging the different types of data, and by deep learning algorithms for slopping prediction based on slopping detection and process data, we are then going the next step to slopping prevention, which is then directly converted or transferred to the BOF automation. And financial impact in that case was $900,000 due to slopping. And the basis of everything we do is our data factory. This is where we turn data into information and information into value. So we are integrating data of multiple data sources. We are enriching the data with metadata information, length time correlation for the full product genealogy to provide you with a full value chain transparency. We are focusing and making you ready for data analytics. We are analyzing the data along the production steps, and we support you with document and manage the genealogy of your product. And we have references. We have lots of references for our products, so everything we promise can be seen based on our references. So let me quickly summarize my presentation. So we are transforming the world of metals as a leading partner. All our solutions are market proven with hundreds of references and ready to use. Our solutions are scalable, and especially when we talk about brownfields, this is very important. So we can start with a very small, let's say, asset package, which is optimizing your most critical asset. You directly have a financial impact, and then we can further enlarge it, because what I have shown now is huge. But we can start, as I mentioned, very small, can be enlarged, and at the end, everything is fully interconnected. And for me, most important is that all our solutions have an impact on the business performance, on the environmental footprint, efficiency and sustainability, of course, on the product quality, as well as the technological leadership. Competition is not sleeping. So this is why it's very important to work, let's say, on the competitiveness to reach in the next step of efficiency and business performance. Thank you very much for your time. And if there are any questions, we are open, let's say, for very nice Q&A. Nevertheless, we are also available via email, via telephone. So whenever you have questions, feel free to reach out to us.
Okay, thank you. Değerli katılımlarından dolayı Sayın Bernhard Stinken ve Can Yalçın'a çok teşekkür ediyoruz. Everything is clear, I think. Teşekkür ediyoruz sunumlarınız için.
Rica ederiz.
Evet. İkinci sunumumuza başlamak üzereyiz arkadaşlar. İkinci sunumumuzun başlığı çelik sektörünün bir sonraki kuşağı, dijital ve sürdürülebilirlik. Sunumu SAP firmasından Sayın Stefan Koch yapacaktır. Sayın Stefan Koch 20 yıldan fazla bir süredir imalat endüstrisi ve IT bölümlerinde çalışmaktadır. SAP'ye 2001 yılında katıldı ve 15 yıldan fazla bir süredir de metal endüstrisine odaklandı. Söz sizde Sayın Koch. It's your turn. Yes, Mr. Koch, we are waiting you.
Can you hear me?
Yes.
Perfect. Now we'll start my video.
Please share your presentation.
One moment, please. So, can you see my screen?
Not yet.
Not yet. Okay.
Not yet, yes.
Then let's try again. Does it work now?
Yes, it's coming. Okay, perfect.
Okay. Perfect. Thank you very much for the introduction. So my name is Stefan Koch. I'm working at SAP in the headquarters. You see it in my background in Waldorf in Germany. And I'm really glad to be here to share with you in the next quarter of an hour, 20 minutes, the SAP perspective on digitalization and Industry 4.0. So looking into the next generation of steel business, where we think it will be digital and also sustainability. I think it's a topic you had already yesterday and today. We also heard that just from the SMS group, how they look into that one. Industry 4.0 is, I think, a very hot topic. And I would like to share with you our perspective, maybe also a little bit from a different angle than we have seen before, because we think it's a broad topic for all areas within a business. So just one word on the history of SAP. So SAP has been founded in 1972. So next year we celebrate 50th anniversary. We are active in the steel industry, I think, since the mid-70s, 76, 77 or so. We started with former ThyssenKrupp parts at that time as first customers, Fürst Alpine, Salzgitter, etc. And in the meantime, we are serving more than 8,000 customers around the globe. We are serving all commodities. We are serving, let's say, all different sizes of businesses, and we also support different areas within the companies. So we have a very, let's say, strong relationship and long relationship with the industry, and so we are really happy to be active in that industry as one of many industries, which is also something special to SAP. We really serve all industries, and that is why we very often can benefit also from, let's say, innovations in one industry, and we can bring that over into the metals industry and vice versa. When we look to the metals industry, so what is the, let's say, priority list of the metals industry? You can find different ways to summarize that. This is one version of it, how we see where the metals industry is going into which direction. So what are the priorities? So we start from the left side. We see clearly everybody's looking into the customer centricity. And if we talk about digital, what does it mean? You will find omni-channel solution selling, real-time order combination. Omni-channel means, okay, you can buy online in a web shop, you can buy with EDI, you can buy with a mobile device, you can buy every channel that you have accessible to get in contact with your supplier. And this is something the metal companies look in at the moment very much, because everybody knows there's a lot of overcapacity competition. So really achieving customer centricity is on top of the agenda in many companies to be better positioned in the market. If we take the next two items here, so connecting and automating the enterprise and running smart factories and digital networks, that goes in hand in hand. That is something you hear very often like digital twins, predictive models, end-to-end supply chain visibility, so the smart factories and digital networks. So that is something where you see a lot of technology taking place. You can go in. We also support that, especially from logistics angle. We have a lot of solutions to addressing that. But what is also one part of that game is that you have a kind of a product configuration. Very often it's about the machine and the production and quality, but that is at the bottom of the configuration. So it's a very detailed one, but it starts somehow to capture the wish of the customer, which brings us back to the left. And it's very important that you can bring in this kind of product configuration, the wish of the customer, down to the production and also in the other direction when you later on deliver that. Ideally, everything fits together and runs in an automatic manner, which means you have to align the different business domains and data models to really have seamless processes running through the company. The fourth topic was supporting value-added services and new business models. That is something everybody looks in. We just listened to SMS Group, SMS Digital, so it's also kind of new business model to work with data for them. But we see that also within the metals industry. So like charge based on performance is something you could imagine on the future. We see business networks. I come to that later on. We see circular economy, which is turning down the business model itself. Because if you think about circular economy, reuse of certain parts, a second life of certain materials, it's a huge topic and it's changing really the business processes. Think about electric vehicles, the batteries, the lives they have, and also the related metal parts that are in that batteries, for example, or in the housing of the batteries. And last but not least, I think that's the big driver at the moment is the responsible and sustainable business from the different angles perspective. The one thing is the energy usage, but it's also about the right sourcing of the material, the conflict materials, etc. That's something you can also address and support to solve the correct sourcing by the help of IT, of digital. And that is also an area we look into. And last but not least, on the right-hand side, you see worker safety. I think a safe working environment is also very important for companies because, of course, nobody should be injured or dying in a company. On the other hand, also nobody wants to work for companies where you don't have a safe work environment. So it's also very important for companies to look into worker safety from a talent retention perspective. If we move on, so what we see in general is also that today we still see this linear supply chain or value chain in metals coming from shovel to the customer that you see here at the bottom. So everybody's working his part of the supply chain. You have the mining company, the steel company, the processing companies, and later on maybe even the automotive company and then the final customer. And everybody is, let's say, optimizing his own stake in that value chain. What we see now is that the companies or the business evolves into business networks because at the end, sensors, nowadays, you can grab every situation in the world with a sensor and transfer that physical event into a virtual model. So you can run then with this kind of data, really business models that are decoupled from physical assets. So if you say a metals company of the future, do you have to own the assets or is a metals company already somebody who just can manage the process of the metal transformation? So from the iron ore to the final product, if you can manage that and everything is in a digital manner, can you be a metal company by just doing that? And what we see in addition is that the activities go cross company borders and also cross industry borders. So we see a lot of more networking and collaboration and working together. That is also why we as SAP offer a lot of different solutions for different purposes, because we want to support our companies to become a so-called intelligent enterprise. We think pieces have to fit together, and like a human being, when you're intelligent, you're thinking about certain situations, you acknowledge what is happening, and then you react to that. A company is similar to that, and that is what we call an intelligent enterprise. We offer, and this is the SAP portfolio somehow on one slide, for different areas, different solutions. I just move to the next one to go a little bit in more detail. So if we start at the top, we see this business network. So that is really the collaboration of a single company working with other companies. Could be in the sales and service area, research and development, but it could be also in logistics, for example, that you team up with a logistic company if you're in metals. So this could be very powerful business networks. That is something we want to support. Below that one, the green line, this is the business process or the processes that you have to run in your company. That is where SAP is coming from. We are not an engineering company that is looking for one machine to optimize and optimizing metal production. Our core competence is really to enable companies to run seamless business processes and to be very flexible and efficient. We are coming from our core and ERP backbone. This is what behind Intelligence Suite. So this purple part here in the middle, where you see HR, for example, we have finance, we have spend management, procurement. So all the classical ERP components that have grown over time. We have different modules for that one. That goes hand in hand on the right-hand side with the so-called industry cloud, where we extend our solution with partners who offer already capabilities that we don't have in SAP, and it doesn't make sense for us to reinvent the wheel, and we rather partner and pull the solutions together. So that's a big focus at the moment, to collaborate with partners, as we did for many years already. And that both areas are supported on the one hand side on top by the so-called experience management. So more and more important today is if you're dealing with your customers, but also with your employees, you would like to collect feedback from your employees and customers, because that enables you to improve your business. You know that from when you get a product delivered that you purchase on a private base, you get asked, okay, what is your experience? You can share that. Similar approach you can take also in a business perspective. For example, COVID-19, a lot of companies use our tools to say, okay, how do you feel, dear employee? Is something missing, etc.? So you can collect this kind of experience. And it's not that difficult to do that in general. I think the challenge is how can you do that really on scale and really fast? Because very often it takes some time to get this kind of service in place. And we have a tool set available that you can do that really fast. The green one here, it's also nothing new to everybody here, sustainability management in general. Everybody looks into that one to improve that, people's life, energy management. That is something where we also have additional solutions available. And at the bottom, you see what is called business technology platform. So we're also offering a technology stack from SAP. On the one hand side, we use that for our applications to run on, but we also have this kind of technology stack that we can enable custom specific scenarios looking into certain areas. If you look into plant maintenance, for example, for predictive maintenance, etc., that is something we can also support with our business technology platform in a very custom manner for one company, for one machine, for a specific asset. But it's also used, of course, in the application area because we also have a plant maintenance module. So this is on one page, the overall SAP offering from a portfolio perspective of solutions. But I would like to share with you some examples because that makes it much easier to grasp, to get the idea behind. The first example is from an aluminum company. It's called ETEM Gestamp. And they shared that case at an event from us, I think last year or the year before already. So the situation is they're doing extrusion of profiles. You see that in the photo at the bottom. And they had a lot of data coming from the past. They have not been automated, they have not been digitized. And the question has been, how can they improve? So at the end, what happened? A colleague from SAP started a project with them. They went there, they gave the colleagues some data from the machine, so data that have been existing already without investing in any automation or additional sensors. And then, because nowadays with technology, with analytics, machine learning and big data, you are in a position that you can make use of existing data in a much faster way, because you don't have to process the data on your own and calculate. You can really use the technology to become better. What did they address with that one? So they could identify certain settings of the machine which leads to the highest yield in production. This has been already for them a big step and improvement, because before they didn't know exactly what is maybe the best combination of parameters to run such an extrusion process. They could also use that kind of technology to identify based on existing data and profiles they had in the past, and you get new profiles every time, so different shapes of the profile. So you have to find out what is the best setting for a new product that you are going to produce, a new profile to extrude it. They could identify already, okay, what is most likely the best setting of parameters to reach a high quality in this area. So it's kind of a proposal and a support for the engineers to say, go this direction, and then you will be very fast in a very good yield rate with your products. And last but not least, also one step was that they could analyze and they could also simulate certain situations with data. This is a case, I think it's straightforward. It's a small company. It's not high tech. It's not a huge steel plant. I think you find endless number of this kind of use cases. It should just demonstrate what you can do with existing data and how you can already benefit from making use of existing data with new technology. And there's more information available on that one. Another case coming from steel, Severstal. I mentioned already plant maintenance before. So a big challenge, and that is also Industry 4.0, digital, and maybe also sustainable to a certain degree, is if you run a big machine, a big asset, a plant, you have thousands of spare parts. And every day you get new spare parts that you have to put in your catalog. If something breaks down, that you can order that spare part, maybe put it even on stock to have it on hand. Because there's change in the machinery, there are upgrades, etc. In Severstal, they have 550 or more daily requests to create such a new piece in their system landscape that they can order that one. The challenge has been that 21% of these material requests, they have been returned because there was something incorrect for the material. So it was wrong classified. It hasn't been a pump, but it was classified as a pump, or there has been wrong color, wrong numbering, whatever. And this is a challenge because 21% returns means you do everything again, so it's very inefficient. By the help of machine learning, they could propose to those who put in the data what are most likely the correct data to put in. You know that from kind of Google type ahead search. So if you type something in, the Google already proposes, okay, this is most likely what you look for, and the same applies here. The difference is this is in a business context. So we have in the background an SAP system. There are a lot of attributes that classify a material, so you can really make use of that. And by the help of machine learning, there's a better proposal rate, and so less errors in the system, and they could get 20% improvements in that process. You see it in the yellow box, by supporting the human beings who put in the system the data with machine learning. In this case, Severstal has worked together with our standard development, so with our developers of SAP for an application, and this kind of proposal is now becoming part of our standard application. And that is what SAP is trying to do all the time. If possible, we bring this kind of processes back into our standard applications so that at the end, everybody benefits from this kind of innovation steps and is not lost because every company has to reinvent the wheel again and again. And so we try to collect this kind of innovations and bring it back into the applications. And this is in our master data governance module now, a standard that has been created by the help of Severstal. Next example, there's also Severstal involved, is coming from Russia. It's an example of how technology can help for fraud. So in Russia, there has been the challenge that there is fraud in the market sometimes because you get a piece of steel and you get a certificate with that piece of steel, but the certificate doesn't match the material because you receive a cheaper material taken from somewhere with the wrong steel certificate. This is an issue because of the price, because you might pay too much for a product. It might be an issue for returns because you get claims, but you haven't produced that material, but the certificate is from you. And it's also an issue if you have like large diameter tubes for pipelines, etc., and you have the wrong material. It's a real environment and also safety issue if you have the wrong material. And that is why the companies in Russia have united and said, okay, let's try to get together this issue solved by putting in a distributed registry for material certificates to have really one trusted source where you can look up a certificate and nobody can put in fake certificates, etc. And they do that by the help of blockchain. So blockchain at the moment, it's very often in context of Bitcoin mining, etc. But blockchain, we see that really largely used now also in the business. And this is an example how you can track and trace correct certificates and ensure that. And there's a consortium in Russia that is looking into that one, but it's not limited to Russia. They want to make it also broader. On the back of that one, if you have that for certificates, you can also use, of course, blockchain for other purposes, because then you can also connect that to logistics processes, etc., which is supporting then the combination and collaboration of different companies, of different players across the industry. So this is one example for how you can use blockchain. Another example also for collaboration and for blockchain is coming from the construction or from the metals industry. It depends a little bit on the viewpoint. So in UK, there's a new high-speed rail network in process. So it's the largest, I think, infrastructure project in Europe at the moment to connect the northern part of UK with London. And there has been a POC that wanted to address a challenge that everybody knows who has ever built a house. You have to bring a lot of different parties together to deliver a certain piece of work. So in this case, there has been the collaboration. You see the logos on the upper left side of Tata Steel as a producer of steel. There's Arab, they do some design and services. And there has been also a consortium with Costain, Strabag, and Skanska. So that is the companies who are doing the construction, and HS2 as the overarching owner of that project. And Wood is a contractor delivering some work at the on-site on the construction place. And the challenge is that if you do a construction, somebody is doing the design. You see that at the bottom in the process. So you have a definition agreed, then you have maybe a model. Somebody says, oh yeah, it's okay what you have done. Then it's released, then it's produced, then it's transported, then it's installed by somebody. And then at the end, somebody wants to have the money and you want to know where that piece has gone and how the overall flow has been going. That's very complex and big projects. And in this case, they did a POC. They have used blockchain so that the workflow between all the different participants is on the back of a blockchain. And because it's on the blockchain, you don't have to put in a central instance where somebody manages everything and is a new player. You have to go in and out and you have to remove. But the blockchain model enables a much faster and more flexible collaboration of different parties that have to work together. In this case, it's addressing the construction industry. It's very interesting. There's also a speech that you see at the left bottom from an event. But you can use the same principle, and that's starting right now, co-innovation with the customer group, for example, for plant maintenance. If you think about a maintenance project, how many different companies are delivering services, you have to onboard them, you have to train them, you have to approve, etc., etc. So at every place where you have this kind of challenges, this kind of blockchain and workflow combination could be very useful. So it's another example how technology and digital can support transformation of the industry for the next generation. And with that, I would like to close my presentation and reinforce a statement that going green and digital is a marathon, but you have to start now and to run ahead. And for that, thank you. And if you have any question, feel free to contact me. We also run an event in 10 days from now. It's also very interesting. You see here's a link, and there will be, for example, also that last example presented. Good. Thank you.
Değerli katkılardan dolayı Sayın Stefan Kok'a teşekkür ediyoruz. Bu ikinci sunumda bitirdikten sonra üçüncü sunumumuza geçiyoruz. Üçüncü sunumumuzun başlığı Endüstri 4.0 çağında entegre üretim ve kalite yönetimi. Sunumu PSI firmasından Sayın Heiko Wolf yapacaktır. Sayın Heiko Wolf 2006 yılında yazılım mühendisi olarak göreve başladıktan sonra 3 yıl teknik proje müdürlüğü yaptı ve 2017 yılında PSI firmasında göreve başladı. 2019 yılından beri de PSI firmasında departman müdürü olarak görev almaktadır. Söz sizde Sayın Wolf. Please your turn.
Yeah, now I'm unmuted. Hello. Thank you for the introduction and welcome from Berlin. My name is Heiko Wolf and I'm speaking to you today from my Berlin home office, but in general, I'm also in the Berlin office of PSI Metals. So PSI Metals, for those who don't know us yet, we have been also for 50 years, now more than 50 years, working on digitalization of production processes in steel and aluminum, so even a little bit older than our colleagues from SAP. And right from the start, we have been working in the ferrous and non-ferrous industries, and through mergers and acquisitions that you see here with various partners in the industry, we have now a strong knowledge in the processes of the industry, but also in products and IT technology. PSI Metals is also part of the PSI Software AG, which is a group of more than 2,000 employees all over Europe, which deals with all optimizations of production and energy flows. So a strong cooperation of which we are part of and where we also share part of the software framework. We focus on one niche only. This is metals, and there we follow our mission of increasing the competitiveness of our customers by optimizing their production processes with production management and planning solutions. We do everything around our product, and on this slide I just want to point out we have become a kind of industry standard in this area of production management and planning of integrated solutions, as you can see, with customers all over the world in steel and aluminum. And with our product, we cover really the end-to-end processes of steel and aluminum production. So from raw material and liquid production, all the way to finished goods, from flat to long to tube, all types of finished production we support. And also on the vertical level, we support everything from long-term planning, medium-term planning and scheduling, all the way to production execution, quality management, and logistics. And this integration of the various parts of the production management solution is also one of our key USPs that I also want to highlight today. Yeah, and even though we've been around for more than 50 years now, of course, this digital transformation journey has also picked up speed for us in the last years, and we are supporting our customers also by building new modern solutions based on data to help them to add value to the existing digital solutions they have. And in today's presentation, I would like to look at what is important for a production management and quality management system in today's era, and then take a little bit of a deeper look into the key areas of quality management, which includes providing quality data, processing it, applying it, and then finally end with some examples and a summary of this topic. So production management and quality management systems have actually come quite a long way over the years that we have been working in this field. Starting with production tracking really for very specialized areas of a mill, for example, just for the melt shop, just for hot rolling topics. Then moving into production tracking that is more holistic across a complete mill. So we have also, of course, then developed solutions like that. Before then going even further and not just looking at production tracking and simple PDI, PDO data provision, but also integrating further functionality in the areas of planning and quality management. So also building this vertical stack. And then finally, today we are at a point where the market expects not just custom solutions for their local plant, but a product that is has the potential to be rolled out also across multiple facilities and to be used in a consistent way across an enterprise. So the state of the art today, as we see it, is that the production management system, the typical level 3 system in a plant, is the key driver of the production, with an integrated factory model that is a up-to-date image of production, and as we heard also in previous presentations, a kind of digital twin of your material, but also your process data. And what you achieve with this is a visibility of all production and quality data along the complete process, and also along the material genealogy of each piece. So each piece, you can trace all its data, its associated production, quality, and commercial information. Go back in time, even go forward with predictive capabilities. Yeah, and finally, as I said, the integration of production tracking, quality, logistics in one consistent solution that works together and is not separated in its functional areas. So this is where we see that production management needs to deliver today. And of course, then come these nice buzzwords of Industry 4.0. They come on top of this. You have now especially the capability to do more with the data that you collect. And this is also the one here on the slide to be highlighted, the big data aspect, meaning that unlike in the past, where an MES system typically got a very limited set of data via clear defined we now look at a situation where we can collect vast amounts of data where we can link it to the structured factory model and access it then from, for example, quality management applications. And based on this data, additional applications become possible. For example, further simulation models and further intelligent solutions from the machine learning and AI areas. So we now have production management plus Industry 4.0 technologies available. Yeah, and for us, one of the real core aspects of the production management is the quality management. And we see it slightly differently than the traditional view, where quality management systems often are local solutions that often act more on a level 2 setup, where you have an in-process quality decision. You measure directly the process data and you make decisions about how to change the process based on this data. And we see it as an added benefit to integrate this quality management data into your higher level production management and even planning capabilities. And what that allows us is to not just look at the data at one production step in line, but to create process data snapshots and combine them with added data from your production management, even commercial data, even environmental data. And then you use this process data snapshot to build additional functionality on top of it. For example, allocation decisions could be made based on this. And a very important point for us is also, we need to make the step from just collecting raw data to having data that can be used as the basis for either operator decisions or, as we also heard before, closed loop AI decisions. Now we need to somehow clean and label the data to be used. And also here, this integration of quality management allows us to build a basis for these machine learning applications. And this will also look into a bit more in the presentation. Of course, also this setup requires a software platform that can allow you to support these functionalities. And here with the quality management, we have the interesting need to fulfill two functionalities. On the one hand, we need high availability to be able to do these in-process decisions. So we need separated quality management modules that are always available and not affected by the rest of the system, for example, by downtimes that might affect you in other areas of the system. At the same time, we want to share the data and we want to have an integrated view on the data to allow things like allocation and final quality decisions. So also this needs to be fulfilled at the same time. And the Industry 4.0 software structure that we chose here to fulfill this is the integration via a central data management and integration bus, so that you have independent software modules that have high availability. So if I need to replace a production management module, the quality management is not affected, or I could even exchange the system for an individual line without affecting the others. But at the same time, we have a central data storage, which we see at the bottom right, which allows to bring that data together in a structured factory model again. And finally, very important is also the human machine interface that allows dedicated screens for analysis and operations, but also integrated business intelligence functionalities. And we also are able to add new data sources very easily via this integration bus. So you can bring new sources, for example, level 1, level 2 sources, sensors, and so on, easily online and use them within the PSI Metal system. So this is the software architecture underneath that enables the production and quality management system to benefit from these new capabilities of collecting this added data. So from the perspective of quality management, the first step, of course, is that we need to collect the data and make it somehow usable for our quality management system. So we saw on the previous slide, we have interfaces, level 1, level 2 sensors, and so on, that provide this data. And then when we have collected it, we need to somehow store it and make it available. And this is what we do with the quality process snapshot or process data snapshot, which is our underlying data structure that collects all the data that you need for quality decisions. And basically what we do here is we build a package of data in which we bring all the relevant data that we collect. This could be material data, This could be process data. This could be commercial data, could be order-related data, all the data we have available at this point. And on top of it, we can also put in higher level values, derived values that give additional meaning to the data. We will see in the next step. They go also in this box into our quality process snapshot. And then when we have this snapshot available, we can use it at any point in time. We can go back in time for the material, see all the snapshots that are available. We can even rerun evaluations later with new rules on past data to add even more value to the quality process snapshot. And what we're building is basically a snapshot matrix that on the one hand has snapshots along time and that has snapshots along the production lines. So you could follow, for example, a material along its genealogy, and you have all the process data snapshots for that material at every step in the production where it was touched. And you have that all available and can analyze it, can go back and forward. Or of course, you could also do it just for one line and follow each material that passes through. And therefore you have a nice basis to use something like a statistical process control that can automatically react to deviations that occur in this production line. And of course, finally, you have a complete set, and this is for us the basis where we can build training for machine learning models on top. We can then build further algorithms on top. With this data, this raw data that we have then in hand, we can then move forward and process and derive additional value on this data. And this is what we do with our quality indicators. So we saw them before already. Quality indicators are a set of rules that basically derive meaning from the raw information. And again, we start with our process snapshot. We have, again, the raw process data and material data in there, but we apply rules and functions, various rules and functions of different complexity to bring out a derived value that then really can be analyzed by an operator. This is, for example, for us, one of the most important benefits that we are taking high dimensional data that is hard to analyze for an operator. We see, for example, with statistic process control also, we bring them into a format and into meaning that an operator then can more easily analyze. And even taking one step further, you also have cases where you have high density data streams that come into your system, and to make them usable immediately, you want to label them, you want to somehow clean this data, you want to put it in certain buckets, and we can also do this. We can also calculate quality indicators directly, automatically with automated data classification. And in this example here, for example, we have data coming in, is checked against a certain threshold in this very simple example, and then placed into 3 buckets, whether this data would force an urgent reaction, a medium reaction, or no maintenance reaction at all. And again, this is has 2 reasons for us. One is, again, labeled data sets for training machine learning algorithms later on, but on the other hand, also transforming high density density from a large feature space into lower dimensional feature space, where an operator can make a judgment based on the data that you supply. So quality indicators, either calculations, models that transform the data into some meaning, but can also be automated classification functionality behind there. And then in our third step, of course, we have now collected the data, stored it in a usable way, and have processed and labeled the data, and finally want to apply it in our system, in our processes. And there we have some traditional ways of reacting, making a quality decision, doing deviation management. But we have also there then now the capability to build predictive and detective capabilities on top that then can use, for example, machine learning functionalities. For the deviation management, just very short words. This is, of course, now one of the benefits that we are fully integrated in the production management and in the planning functionalities, because we can directly from those functionalities use our quality data, our deviation management. So in the first step, of course, we could change the classification of a product, disposition or the grade of the product. This is a typical reaction to ensure that we can still use this product that now has a lower quality. We still find the best potential use for it. We can, of course, also try to change the production. This is more advanced functionality where, on the one hand, we are able to change the PDI, the process parameters for the further production steps to make up for the lacking quality that we have that we have detected. This is what we call the conditional release functionality. And taking one step further, we can even use our order dressing functionality that has in the beginning calculated the production route to change the routing of a material. So here we are able to say this material, if we continue on the same production route, we will not be able to achieve the target quality for this order, but we have the capability to add rework or to have a completely different production route to still achieve the target quality of the material. Yeah, and of course, we can also take the hard step of deallocating and scrapping the material, but this is, of course, then some last resort reaction. So all this functionality that I talked about before is, of course, possible based on heuristics, based on deterministic decision-making, can be done by operators and so on. But we also want to go further and also employ AI models, of which there are many available and in use in the PSI Software AG in various areas, also at our sister companies in energy and logistics. And we all use a predictive and detective pipeline that consists of these 5 steps, from acquisition to putting a model into online prediction. And these steps of the pipeline also map again back to our quality process snapshots. So data acquisition is exactly what I showed before, of collecting this data and putting it together in these snapshots. And then data preparation is exactly the next step of having the quality indicators available that you need to later build further functionality on. And then come into play our machine learning functionalities to be able to use this data to train models, to evaluate models, and to finally also put them into an online mode. And so the quality process snapshot with indicators is our input, especially for the training part of this pipeline, but also then later in the online mode, continuously the model is using these quality process snapshots to make online predictions. And I have some examples for this in the next slides. One example where we applied this is the defect prediction at a hot strip mill, where here for a customer, we had the challenge that material showed defects that were created during hot rolling, but they only were detected much later in production. At such a late point that either you had done unnecessary production steps or you had missed the point where you can still take steps to repair or rework this material. And so here, the added benefit is that we have built a model that takes the process data and quality data from hot rolling and previous slab data and uses it to predict these hidden defects that come further downstream. And what it enables the customer is that after hot rolling, the customer already gets information to say, this material has a high likelihood, you have a certain percentage of likelihood of a defect in this material, and you can then decide what you can do with this. You can either do some rework or take it out of production right there. In the next step, with the same customer, we are taking this also a step further, where we don't just make the prediction, okay, there is a hidden defect that will show, but also we take further information, namely of the production lines further downstream, to also give an indication of what would be the best route in this environment. So this is in a way an AI-driven forward dressing. So after hot rolling, again, we have learned about this material, that there is a likelihood for a certain defect, but we can then also choose the best route to avoid the defect or to lower the likelihood that it will occur. So we can use here our trained model to get potential optimal production routes. And again, this is in the first step used to show this information to an operator for a decision. But of course, after evaluating the model, this could be also then used in a closed loop scenario. So these both relied mostly on numerical data directly from the lines, but we can also have other types of data in our quality indicators. So the data structure is very open. You can store essentially anything in there. And one example for that is image data. We also do defect detection on steel surface images. In this case, we have applied a neural network that is basically in a two-step process detecting whether there is a defect at all, and then segmenting the image to show the areas where there are defects. And also this, the image itself, but also the detected defect areas can be then stored again in a process data snapshot, and then can be used later and retrieved, shown to an operator, or even being used in an automated way. So any type of data really you can store there, and always remember it's all modeled back to the structured factory model, to this digital twin of your material, of your process, so that you can always drill into and find this higher detailed data along the whole material genealogy of your material. Finally, I would like to give one example where we use this system. So we have implemented this integrated quality management with quality indicators and a large amount of data at a big Asian steel producer. And there we have a set of lines, and you see that we have hundreds of quality indicators there that are defined and that are fit with high density data from these various lines. And just to give an indication here, we have, this is from 2019, so in the meantime we have collected much more data there, but this is the last data that we have received there, that we had there billions of measurements and even millions of stored pictures that are assorted or assigned to this. And it's a large amount of data that we're collecting there. And the important thing is, by putting them into these process data snapshots, they do not affect your performance of your normal production management or MES functionality, but they are available when you need them to drill down into and to use for other functionalities. So in summary, what I showed today, we have here a quality data structure to store all kinds of quality data, and important, really related to the material genealogy and to the points in time. So you can always find exactly the data that you need for a certain scenario. You have these quality indicators, which is important then to derive meaning from the raw information. And for that, you can also use some automated classification, labeling, and this is especially important to handle large and unstructured data streams, so that you can have a data set that you can show either to an operator or use as the basis for machine learning algorithms. We have the integration with production management. So this is a very important point, that you can directly use this data for deviation management and to propose the correct possible action. And there also you see that we are working on machine learning applications that support the operator, but that also allow in the future some closed loop deviation management applications based on quality deviations. It's well integrated in the production management environment, but also to the automation environment. So also for in-process quality decisions, this can be used, but also for higher level functionality like allocation decisions. And finally, with our Industry 4.0 system architecture, we guarantee this high availability, but also the extensibility of the system. And finally, if you have further information needs about advanced quality decision and quality management with PSI Metals, we have a tech talk available here on Vimeo, and we can also arrange an appointment for a deeper look into our systems if needed. So thank you very much for your attention.
Evet, Sayın Wolf'a teşekkür ediyoruz. Sunumlar o kadar güzel sunuluyor ki dinleyicilerden hiç soru gelmiyor. Tekrar teşekkürler hepinize. Değerli katkılarından dolayı Wolf'a da yine teşekkürlerimizi sunuyoruz. Evet, biraz geç gidiyoruz ama konular gayet yoğun bir konu olduğu için sabırlarınızı istirham ediyoruz. Evet, 4. sunumumuzun başlığı geleceğin tesisi dijital dönüşümde nasıl başarılı olunur? Sunumu ISS firmasından Sayın Martin Provencher yapacaktır. Sayın Martin Provencher, operasyon ve bakım yönetimi ve bilgi teknolojisinde 25 yıldan fazla deneyime sahiptir. ISS'ın global madencilik, metal ve malzemeler müdürü olarak da çalışmaktadır. Evet, Sayın Provencher'ı dinliyoruz. Yes, your turn, Provencher.
Thank you very much. Hello, everyone. Thank you for attending this session on the Mill of the Future. My name is Martin Provencher. I'm industry principal for mining metals and materials with OSIsoft, makers of the PI system and now part of Aviva. So if I do, okay, good. So today I'll share with you some insights, on some good research studies in the market. We'll start with a brief introduction and we'll look at the value that the digital transformation strategy can bring to a steel mill. We'll then discuss about some of the digital initiatives that are key to improve efficiency and help reduce costs, such as analytics and AI. I'll also cover a hot topic these days when we talk about digital twins. And of course, I'll share with you some good use cases and conclude with some key takeaways. Now let's start looking at how AI is growing fast within the industry. With the growth of IIoT devices that are being deployed globally, it opens the door to lots of opportunities. According to an IDC study on artificial intelligence, IDC predicts that globally the AI market will reach 240 billion of spendings by 2024. So it's a lot of money and it has begun, but this is a step-by-step approach. I strongly recommend companies not to start with AI right away. Start leveraging all the data that you have, start leveraging the different levels of analytics, and then eventually get into AI. 80% of the value can be obtained with simple analytics or predictive analytics just by using those tools. So it's a step-by-step approach. Now let's start talking about digital transformation, because if we want to move towards that journey of using those analytical tools, we need operational data. We need to transform our business to have a digital business. A Navigant research study in 2019 actually identified, and that was back in 2019, so it's a couple of years ago, but it's still pretty good. And actually today it's even better. At that time, they realized that the average time to get return on investment was about 7 months when companies start a digital transformation journey. So there is huge value out of it. And it's a fact, it is changing the industry. It's especially when you start leveraging operational data. Of course, digital transformation is not happening at the same rate everywhere. According to a McKinsey study, only 16% of companies succeed in their digital transformation. So companies invest millions of dollars in digital initiatives, Industry 4.0, IIoT, advanced analytics, but they're not getting value out of it. And the reason is very simple. Operational and IoT sensors data are great. They have great value, but this is raw data. And vast amounts of raw data might be very difficult to take into consideration. And data does not mean necessarily information. It has to be contextualized first. We need to make sure we have people that have access to that data so they can leverage that data and they can take advantage and generate value for the business. So here, those are the main areas where we see that our customers have been able to get value out of their operational data. Again, lots of value can be obtained in different areas. The main idea here is to capture all that operational data, bring it into one placeholder so that you have one single version of the truth. And then once you have one single version of the truth, of course, you can start doing real-time condition process monitoring, for example, in terms of process productivity. Your people, process engineers, they already know a lot of information. They already have strong knowledge that they can leverage, or that the organization can leverage. And the idea is to capture all that knowledge that they have. In terms of energy and water management, I mean, again, the same thing. I mean, energy consumption is a big thing in steel companies. I mean, you might want to be able to have a global view on your energy consumption. Lots of times you have different energy measurement systems that are not linked together, so it's difficult to have a global view, global visibility on the energy consumption within a mill. So now, once you have all of that information to one placeholder, it becomes very easy to see what's happening. In terms of asset reliability, of course, I mean, reliability engineers, again, have lots of expertise in terms of what causes failures on our assets. So once they know the conditions that lead to failure, they have the possibility to implement those conditions into their real-time operational data platform, so that that platform will actually be doing those analysis for them, and they don't have to do it anymore. And of course, the platform will also be able to integrate with the CMMS system, with a computerized maintenance management system, so that a work order can be generated automatically. So this is a big thing, lots of improvement in that area, lots of possibilities, lots of value in that area. In terms of environment, health and safety, again, same thing. Environmental people, they know the conditions that lead to environmental deviations. So once you have all that data being captured into one placeholder, you have people that can implement those conditions into that operational data platform. Becomes very easy to improve compliancy aspects. And of course, I mean, quality is the same thing. And ultimately, once you have all that data coming from all those different assets, different areas, different processes, becomes very easy to implement key performance indicators and, of course, generate any kind of reporting. And this is exactly what Algoma Steel has done. Algoma Steel is a fully integrated steel plant in Canada, or SR Steel, actually. The company wanted to improve on its manufacturing performance, so they were adding new equipments. And of course, whenever you had a new equipment, it comes with its own computer technology, control system, or PLC. So the problem that they were facing is that they had many different control systems, many different computer technologies, and none of them were talking to each other. So they brought in a real-time operational data platform. They started capturing the data from all their different control systems, and now they have global visibility on all their assets. This is the first step. Having visibility on your assets globally is the first step towards analytics, the analytics journey, or the digital transformation journey. And this is exactly what they have done. Now, once you have visibility, once you have global visibility, what are the next steps? Well, definitely start leveraging analytics and even artificial intelligence. Now, in order to achieve successful journey towards analytics, first you need, of course, like I said, to collect, contextualize all that operational data, and all the data needs to be taken into consideration. A very good study performed by Deloitte Mining, although it's in mining, I mean, I think it is really relevant to take that into consideration. It was the fact that, the highlights of it is that they were saying that, yes, it's important to take data to do analytics, but not only historical data, not only real-time data, all of that data must be taken into consideration. And once you have, real-time, historical, even future data will be important to take into consideration. And once you leverage all that data, well, they were expecting that you can get typically an increase in terms of productivity by 10 to 20%. So there's significant value in leveraging all of that data. And here we see a very good example of a successful digital transformation journey that Liberty Ostrava, located in Czech Republic, have done. They looked at the automation of their blast furnace and maintenance processes, and they started monitoring the beginning and the end of the tap to calculate the burden on the blast furnace. And all of this resulted in better production processes, and of course, an increase in terms of quality. So they also use that operational data to implement predictive maintenance, based on known conditions with simple analytics that their engineers already knew. So a very good example here. And as you can see, you can look at the link here. You can see the whole customer presentation, approximately a 45-minute presentation, very interesting presentation. And as you can see, they've achieved quite good results there. Another very good example here is with ArcelorMittal, Dofasco in Canada. I mean, again, using real-time operational data within all their production departments. They realized that data was quite important for them to improve their maintenance practices. So they did an RCM analysis. They were having an issue with a taphole refractory that was actually eroding abnormally. So following the RCM analysis, they've identified the conditions that were leading to those failures. And actually, they've implemented those conditions into their real-time operational data platform. And they have integrated with their CMMS so that a work order would be generated automatically before the failure happens. So a very good example here of a simple predictive maintenance, because now we're predicting a failure. Even though we're not using advanced analytical tools, we are still predicting a failure. So very good example here from ArcelorMittal Dofasco. Now, another important topic here is the fact that we'll start talking about digital twins, and basically it's here. It already existed years ago. It was used during the Apollo launch back 30 years ago. I mean, it has been there for a long time. Now, what is a digital twin? I mean, of course, you can take a picture and say, hey, I have a digital twin. Well, you have a digital picture. Now, to have a digital twin, you have to have first a digital foundation to get all that operational data and build the structure of your asset, a digital structure of your asset. And then you can start talking about having a digital twin, because now you have the structure of your asset and you have that real-time operational data that is aligned with that asset. So now you're talking about a structure of a digital twin with the data. And then, of course, once you have that into your operational data platform, you can start using advanced analytics or even simple analytics with the examples that we've seen before. And then you can, of course, bring value to your operations. Now, a very good example here that I wanted to share with you, even though it's not in steel, I think it's still very interesting to share that story. It's Norsk Hydro, and again, it doesn't mean that no customers are doing it. It's just that I think this example is quite interesting to share. Norsk Hydro in Brazil, I mean, it's a mine company. They have 3 different mines and 1 headquarters back in the south of Brazil, I mean, in Rio de Janeiro, and the 3 mines are in the north of Brazil. And as you might know, I mean, Brazil is quite large. So basically their people, their experts are located in Rio de Janeiro in their center of excellence, and they are actually analyzing the operations that's happening at the mine sites. So in real time, so they can see in real time what's happening at the mine site for all their assets. And while they're looking at that, they also have all the, of course, the structure of the asset. They have all the real-time operational data of those assets. And now they can do simulation with that data. And they can even bring back information to the operators. For example, in this case, we see a truck. I mean, they can bring back information to the operator saying, hey, Mr. Operator, you should now start reducing your speed to increase the life expectancy of your assets. So this is a very good example of a successful use of the cloud and digital twins. So that's why I wanted to share with you that story. It's a very good story from Norsk Hydro. Now, the next topic or the next step that we will be looking at is basically autonomous operation. And when we say autonomous operation here, we're talking about using artificial intelligence to replace someone, to replace an operator. So this is a big thing. And this is actually coming in the industry. We have customers that are starting to work with AI, with artificial intelligence tools, and that are actually looking into it within the steel industry. Of course, I cannot share any customer information unless customers have presented it. What I do share, what I can share is a customer in the cement industry that has actually presented that story. And again, that is fully applicable to the steel industry. And we have people, customers that are starting to look into it. Now, in this example, Cemex is a cement company. I mean, they are looking at the kiln. I mean, the kiln is a very large oven, rotating oven, similar to a furnace that in the steel industry. It's operated at 1500 degrees Celsius, so it's very complex in terms of operation. And their objective, they presented it back in 2018, and their objective was that by 2022, so this is next year, their kiln operations will be fully autonomous. So this is a big step in the industry. And again, this is in cement, but applicable to steel. So they looked at a portion of the operations of the kiln cooler operations, and they basically looked at it in 3 different steps. So they first started looking at it. Are we able to predict how the operations will be affected using specific set points? So once they were comfortable with those predictions, they said, okay, now are we able to build an AI model, an artificial intelligence model, where we could identify which would be the optimal set points to use for the best operations, to improve quality, to improve yield, etc. And once they were comfortable with those prescriptions, well, they basically connected it to their control system. So now, of course, I would not recommend any company to start with this, but Cemex has done quite a long journey towards their digital transformation, and they are there today. So now their prescriptions are actually being sent back to the control systems, and the control system is actually being managed fully autonomously. Now, this is a very good success story. Again, from a security perspective, Cemex is keeping their operators there because, of course, they don't want to have any incidents, because now we're talking about safety. So in this case, they're calling it autopilot, but autonomous operations are currently being happening at Cemex. So a very good example of a successful autonomous operations implementation. And again, this can be applied to any kind of furnaces in the steel industry or any other assets that we can think of. Now, in conclusion, I mean, what I would like everyone to remember is that new technology requires data management, and a successful digital transformation will enable improvements in many different aspects, from safety to maintenance to operations. But of course, in order to succeed, you need a real-time operational data platform. So you need a platform that will, of course, allow you to capture all that operational data. One thing, capture all the context that goes with the data. What was the status of my assets when I captured that data? Was it in operation? Was it in maintenance mode? Was it, has there been an emergency button pressed there? So all that context is critical, because we will use that context later on with advanced analytics. And of course, once you have that, all that information, you can start thinking about using analytics and AI, artificial intelligence, to enable new era of operations, going from reactive maintenance to predictive maintenance, or even prescriptive maintenance, or even you can start thinking about using AI and use autonomous, or think about autonomous operations, as we have seen. So thank you very much. I hope you've enjoyed that presentation, and I don't know if we have time for questions, or but look forward to helping you. If you have any questions, you have my contact information on this slide. So happy to help if needed.
Thank you, Mr. Provencher. Evet, soru alamıyoruz ve hemen 5. ve son oturumumuza başlıyoruz. 5. ve son sunumumuzun başlığı, en iyi kalite, üretkenlik ve esneklik için üretim zincirini dijital yollarla optimize etmek. Sunumu Primetas firmasından Sayın Can Ergün yapacaktır. Sayın Can Ergün, meteoroloji ve malzeme mühendisi. 2013 yılında Ereğli Demir ve Çelik fabrikalarında işletme mühendisi olarak sektöre başladı. ArcelorMittal, DIASPARRO Çelik grubunda Türkiye'de ve İngiltere'de çalıştı. 2019 yılından beri de Primatas Avusturya'da satış müdürü olarak devam etmektedir. Can Bey, söz sizde. Buyurun. Biraz süremizi açtık ama sizi de beklettik. Evet Can Bey, buyurun.
Merhabalar.
Merhabalar.
Kadir Bey, teşekkür ederim. Çelik sektörünün değerli temsilcileri, hepinizi Primatas adına saygıyla selamlıyorum. Bugün size ekranımı görebiliyorsunuz herhalde, değil mi Kadir Bey?
Evet, evet, gözüküyor Can Bey. Ekran paylaşacaksınız değil mi?
Evet.
Evet, okey.
Şu anda geldi sanırım. Bugün sizlere en iyi kalite, üretkenlik ve esneklik için üretim zincirini dijital yollarla optimize etmek konulu sunuyu sunacağım. Bugün nelere bakacağız? Bugün bir çelik işletmesinin odaklandığı temel konular nelerdir? Akıllı bir çelik işletmesinin gereksinimleri nedir? Geleceğin akıllı çelik tesisi nasıl olmalıdır? Bu sorulara cevap arayacağız. Bu sorulara Endüstri 4.0'ın 3 temel otomasyon çözümüyle cevap vermeye çalışacağım. Çelik işletmelerinin başlıca odaklandığı konular nelerdir dersek, bunlar karlılık ve büyüme, tam zamanda teslimat, yenilikçi ürünlerin pazara sunulma süresi, müşteri deneyimleri, piyasa dinamikleri ve çevre ve iş güvenliği mevzuatları olarak sıralayabiliriz. Akıllı bir çelik işletmesi nasıl olmalıdır diye sorarsak, bunu bize yine en iyi böyle bir işletmenin gereksinimleri cevap verecek. Akıllı bir çelik işletmesinin işletme kararları kurumsal bir yönetim tarafından edindiği dijital datalarla yapılmalıdır. Akıllı bir çelik tesisinin tedarik zinciri yönetimi çok önemli. Bunu dijital bir yolla yapması önemli. Ham madde tedariki, ham maddenin zamanında ulaşması, ham madde stoklarının optimum düzeyde tutulması, bakım ve onarım işletme malzemelerinin zamanda tesis edilmesi ve üretimin aksamadan yolunda olması, tam zamanda teslimata uyulması ve müşteri memnuniyeti tabii ki de. Ve sonuç olarak yenilikçi ürünlerin pazara sunulma süresi. Burada yenilikçi ürünler derken piyasa dinamikleri devamlı değişiyor. Elektrik çelikleri, yüksek mukavemetli çelikler, yeni nesil alüminyum, çinko, magnezyum kaplı ürünler. Bu ürünlerin pazara en kısa sürede sunulması gereklilikleri var akıllı şirketlerin, akıllı dijital şirketlerin. Bunları da kalite optimizasyon sistemleriyle yapmak, hızlandırmak mümkün. Ve müşteri deneyimi önemli. Müşteriler e-ticarete yöneliyorlar. Müşteri şikayetlerinin azaltılması, sıfıra indirmesi lazım. Bu da yine kalite optimizasyon sistemleriyle mümkün. Tedarik zinciri yönteminin de optimum hale getirilmesi de üretim yönetim sistemleriyle mümkün. Hattın da sürekli olarak aksamadan ilerlemesi de yine bakım uzmanlık sistemleriyle mümkün. Akıllı tesis bu gereksinimlerin arasında bulunuyor. Peki geleceğin akıllı tesisi nasıl olmalı? Biraz buna bakalım. Geleceğin akıllı tesisinde olması gereken özellikler temel olarak proses optimizasyonu, teknolojik paketler, robotlar, durum izleme, condition monitoring diye de anlaşılabilir. Akıllı sensörler ve sistemler, güç ve sürücü çözümleri. Bunlar her bir ergitme, slab döküm ya da sürekli döküm, haddeleme ve nihai hatlar için geçerli. Entegre bir çelik tesisinde bu akıllı tesislerin arasında bir de iç lojistik faaliyetleri var. Bunlar da akıllı tesiste otomasyonla yönetilmeli. Örneğin hurda sahasının yönetimi full otomasyonla olabilir. içerideki ara mamul akışı online döküm çizelgeleme sistemleriyle olur. Vinçlerin içerideki iç lojistik vinçlerinin takip sistemi yine otomasyonla olacak. Ara ürünlerin modüler nihai taşıma ürünleriyle, üniteleriyle taşınması, ürün tanımlama, buradan kastımız ürünlerin QR koduyla içinde bütün kalite parametrelerinin yer aldığı QR kodlarıyla kodlanmasına örnek verebiliriz. Yine akıllı tesiste bunların üzerinde dijital birlik adını verdiğimiz bugün size 3 tane otomasyon sisteminden bahsetmek istiyorum. Bunlar Endüstri 4.0 çözümlerimiz. Bunların birincisi üretim yönetim sistemi, Production Management System diye de biliniyor. İkincisi süreç boyu optimizasyonu, bu da True Process Optimization. Bu da ileri seviye bir kalite kontrol sistemi. Üçüncüsü ise bakım ve varlık teknolojisi. Bu da Maintenance Asset Technology denen ürün. Bu da bakım alanındaki uzmanlık sistemi. Bu üçünden detaylıca bahsedeceğim. Ama bunun yanında akıllı çelik tesisini metal zekası yani Metals Intelligence ile yine desteklemek gerekiyor. Dijital asistanlar, fiziksel ve hibrit modeller, veri analitiği, iş zekası, dijitalleştirilmiş bilgi birikimi, veri deposu ve akıllı servisler. Bunlar abonelik sistemiyle artık otomasyon sistemleri kurulabiliyor şirketlere. Artık bir dijital sistemi satın almasına gerek yok çelik üreticisinin. Bunu yıllık anlaşmalarla leasing yöntemiyle alabiliyor. Aynı şekilde yedek parçalarını online mağazalardan alabiliyor. Servis anlaşmalarını standart hale getirebiliyor. Ve hızlıca dijital ortamda bunları sağlayabiliyor. İşte bütün bu sistemlerin olduğu bir tesisi geleceğin akıllı çelik işletmesi olarak tanımlayabiliriz. Şimdi bu size bahsettiğim 3 otomasyon sisteminden birincisi olan üretim yönetim sisteminden bahsedeceğim. Üretim yönetim sistemi en yüksek verimlilik için planlama, çizelgele ve yürütme sistemidir. Burada bu slaytta çelik üretim sürecini görüyoruz. Normalde çelik tesisleri sipariş aldıktan sonra geriye dönük bir planlama yaparlar. Sipariş aldıktan sonra önce bobin talebi içerideki ünitelere, daha sonra slab, döküm ve cevher talebine kadar gider. Bu ark ocak testlerde tabii ki de hurda talebine dönüşüyor. Peki Production Management System, üretim yönetim sisteminin farkı ne? Üretim yönetim sistemi ile demir üretimden itibaren üretim planlaması online olarak yapılıyor. Tabii bu online sistemde çelik kalitesindeki geçişler, üretim seküansındaki geçişler hattı en karlı çalıştıracak şekilde ayarlanıyor ve hattın bir ucundan bir ucuna kadar en optimum şekilde planlanıyor. Bu sayede gereğinden fazla üretim, overrolling dediğimiz gereğinden fazla stoğa gidecek malzemelerin önüne geçiliyor ve aynı şekilde ham madde stokları da optimum düzeyde tutuluyor. Sadece üretimin planlanması değil, aynı zamanda PMS sistemi slab sahası ve bobin sahalarının da yönetimini yapabiliyor. Buradaki vinçlerin de yönetimini, konuşlanmasını kontrol edebiliyor. Yine PMS aynı zamanda ürün ve kalite takibi ve yürütme yapıyor. Ürün spesifikasyonun hazırlanması, ürün tasarımını da gerçekleştiriyor ve planlama ve çizelgeleme döngüsünü tamamlıyor. Bunu böyle bir sistem olmadığı takdirde bu planlamalar manuel olarak Excel ortamlarında yapılabiliyor. PMS sistemi insan faktörünü olabildiğince azaltarak şirket karlılığını optimize ediyor. Bu slaytta demir çelik tesislerindeki sıcak şarjın öneminden bahsetmek istiyorum. Üretim yönetim sistemi bir çelik tesisinde sıcak şarjı doğrudan ve maksimum düzeyde yapmak için bir planlama yapıyor. Bir çelik tesisinde sıcak şarjın önemi şu, ara mamulün, slab veya kütüklerin hızlı bir şekilde doğrudan ve sıcak olarak slab fırınlarına ve sıcak hattaneye yönlendirilmesiyle büyük bir ısı avantajı sağlıyor çelik şirketleri. Ve bu ısı avantajının yanı sıra aynı zamanda sıcak hattanenin üretim hızı ve karlılığı artıyor. PMS sisteminin klasik yöntemlerden farkı, üretim planlama yapılırken üretim yönetim sistemi aynı zamanda sıcak hattane, sürekli dökümler ve çelikhane seviye 2 sistemleriyle interaktif şekilde haberleşiyor ve optimum düzeyde bu slabların sıralanmasını sağlıyor. Tesislerin en hızlı şekilde çalışması ve en verimli şekilde çalışması için. Nihai olarak planlama ve çizelgeleme ile entegre tedarik zinciri optimizasyonu olan bu programla orta ve uzun vadeli satış planlaması yapılabiliyor. O orta vadeden kastım 6 ay veya uzun vadeli 6 ay, 1 ay, 1 yıl vadeyle satış planlaması yapılıyor ve üretim hattının en karlı şekilde çalışmasına yönelik optimize ediliyor üretim planı. Bunu aylık ve günlük baza indirmek mümkün. Faydaları neler? Faydaları anahtar performans indikatörü güdümlü, yani KPI güdümlü planlamalar yapılabiliyor. Değişik konjüktürel duruma göre stoğa üretim ya da siparişe göre üretim şeklinde konfigüre edilebiliyor. İkinci bahsetmek istediğim sistem süreç boyu optimizasyon, True Process Optimization ürünün ismi. Bu IT tabanlı üst düzey bir kalite kontrol sistemi. Şimdi bundan bahsedelim. True Process Optimization yani TPO birbirine bağlı operasyonel mükemmelliği 4 seviyede tamamlıyor. Bunu şöyle kuruyoruz yeni bir tesise. Öncelikle 4 aşamadan birincisi veri. Veri seviyesinde entegre çelik tesisindeki çelik ünitelerini, çelik üretim ünitelerini birbirine bağlıyoruz ve bunlardan kaliteyi etkileyen parametreleri topluyoruz bir arayüzle ve eksiksiz bir ürün seceresi çıkartıyoruz. Bu ne demek? Bir ürünün cevherden, sıvı çelikten ta ki galvanize ürüne kadar ki bütün aşamalarını kaydediyor. Kaydediyor bu sistem ve bobinin uzunluk boyunca verilerini saklıyor ve kesintisiz kaliteli veriler elde ediyor. Yani anlamsız olan verileri elimine ediyor ve temiz bir veri tabanı oluşturuyor. İkinci aşama görselleştirme. Veriler toplandı demir çelik tesisinden, yüksek fırınlardan galvanizleme hatlarına kadar diyelim. Şimdi bu bu verileri anlamlı bir şekilde görüntülemek önemli ve de bu verileri KPI, anahtar performans göstergeleri ya da istatistiksel proses kontrol hesaplarıyla anlamlı hale getiriyoruz görselleştirme kısmında. Business Intelligence, interaktif raporlama ve dokümantasyon şeklinde görselleştiriyoruz verileri çeşitli dashboardlarla. Bu bilgiler aynı zamanda şirket yöneticilerin cep telefonlarına, tabletlerine, bilgisayarlarına hızlı bir şekilde ulaşabiliyor. Web tabanlı bir görselleştirmeden bahsediyoruz. Dijital parmak izi. Dijital parmak izinden kastımız artık bir bobine ait bütün kalite bilgilerini bobinin uzunluğu boyunca bir QR koduna sığdırabiliyoruz. Bu şekilde görselleştirme seviyesi. Bunun üzerinde bu seviyeyi de tamamladıktan sonra artık destek seviyesine geçiyoruz. Bu ne demek? Verileri topladık, görselleştirdik. Artık bu verilerle üretimi ve kalite kontrolü destekleme seviyesine geldik. Bu toplanan ve görselleştirilen verilerden yola çıkarak üretilen mamulün otomatik olarak derecelendirilmesi sağlanıyor. Bu ne demek? Üretilen ürün müşteriye gitmeye hazır mı? Gitmemesini engelleyen problemler varsa bunlar nasıl giderilmelidir? Bununla ilgili otomatik bir karar verme mekanizması. Aynı şekilde üretim operatörleri ve kalite kontrol inspektörleri için dijital asistan mevcut. Hattın önünde bekleyen ara mamuller ve hattan çıkan nihai mamuller hakkındaki kalite geçmişini ve kalite sonuçlarını operatöre asiste ediyor sistem, optimizasyon sistemi ve onlara karar desteği veriyor. Örneğin bir sıcak hattanede bir sıcak bobin üretilirken üretim limitlerinin üstünde bir alarm verildi. Ve operatör ne yapacağını bilmiyor. Orada operatöre bu hatanın neden kaynaklandığı, tekrar olmaması için ne gerektiği ve elindeki kusurlu mamulün nasıl telafi edilebileceği hakkında karar desteği veriyor. Süreç denetimi ve tahmine dayalı bir kalite kontrol sistemi de mevcut bu destek seviyesinde. Artık mevcut üretim parametrelerinden yola çıkarak kural bazlı bir sisteme dayanarak artık kusur daha oluşmadan tahminlerle üretime kademesine destek veriyor. Bundan sonraki seviyesi öğrenme seviyesi artık. Öğrenme seviyesinde edinilen bilgiler 3 sene, 5 yıl süreyle ya da 10 sene süreyle veri tabanında toplanıyor. Buradan data analitik yöntemiyle çelik üreticisinin kronik problemleri, kalite kusur problemleri ne çözümler bulunuyor ve bulunan bu sistemler sistemin tekrar kural editörüne gidilerek tekrar gerçekleştiği takdirde çelik üreticisine uyarılar veriyor ve yol gösteriyor. Diğerleri veri analitiği, yapay zeka. Yapay zekada artık yapay zeka algoritmaları kullanıyoruz bu toplanan bilgiler sayesinde. En son bu Çin'deki Tangshan tesisimizde toplanan verilerle hangi kimyasal analiz durumunda, hangi haddeleme parametrelerinde çelikten istenen 3 ana özellik olan akma mukavemeti, çekme mukavemeti ve yüzde uzama değerlerinin tahmin eden bir program yazdık ve bir ürün haline getirdik. Bu tarz algoritmaları çoğaltmak mümkün. Aynı şekilde çelik üreticileri de bu optimizasyon sistemlerini kullanarak kendi ihtiyaçları ve sıkıntıları doğrultusunda çözüm modellerini, algoritmalarını bu data analitik sayesinde topladığı bu düzenli veriler sayesinde yapabilirler. Ve kurumsal bilgi birikiminin dijitalleşmesi gerçekleşiyor. Bu ne demek? Şirketler yaşam döngüsü boyunca hem işletme olarak hem kalite kontrol olarak birçok bilgi birikimi ediniyorlar. Maalesef bu bilgiler şirketten çalışanlar ayrıldıkça ya da emekli oldukça onlardan şirketten ayrılıyor. Ancak bu tarz sistemler sayesinde bu bilgiler kurallaştırılarak bu software'in içerisinde monte ediliyor. Bunun haricinde bir de know-how servisleri var, bilgi birikimi servisleri süreç optimizasyonunun. Burada da ürün geliştirme, örneğin elektrik çelikleri, yüksek mukavemetli çelikler, yeni nesil kaplamalı çeliklerin geliştirilmesinde bu veri tabanları kullanarak bu ürün geliştirme süresi kısaltılıyor oldukça. Örneğin Çin'deki Tangshan tesisimizde yaklaşık tesisin kurulmasından bir sene içerisinde DP 1100 doğal faz, çift fazlı çeliklerin üretilmesi gerçekleşti. Bu normal bir tesis için çok kısa bir süre. Know-how servisleri aynı zamanda proses optimizasyonu, diğer simülasyonlar, veri analitiği ve danışmanlık hizmetlerini içeriyor. TPO dediğim gibi ürünün secere takibini yapıyor. Ta çelikhaneden hattanelerden galvaniz hatlarına. Bu bilgiye ulaşım ne demek? Örneğin çelik üreticisi bir galvanizli çelik üretti ve burada bir kalite kusuru var. Bu kalite kusurunu geriye dönük slab döküme kadar, çelikhaneye kadar gidebiliyor ve hızlı bir şekilde saniyeler içerisinde esas kök nedenini bulabiliyor bir hatanın. TPO sisteminde ayrıca her bir üretim biriminden sonra bir kalite kapısı var. Bu ekranda görmüş olduğunuz çelik ünitelerinden sonra belli kurallar dahilinde bir kalite kontroller var. Ve herhangi bir uygunsuzluk durumunda sistem alarm veriyor ve bu alarma karşılık kök neden analizi veriyor. Böyle bir hata çıkabilir. Kök neden analizi veriyor ve düzeltici önleyici faaliyetler öneriyor. Bu sistem bir kurallar manzumesinde gerçekleşiyor. Bu sistemin arkasında bir kural editörü var dedik ve kural yürütme motoru var. Burada bir sıcak hattane örneği var. Çok kısa. Şerit hattede bir merkezleme hatası tespit ediyor sistem ve bu bobinin kabul olabileceği ya da kötü bir şekilde ortaya çıkabileceğini söylüyor. Ve buna uygun kök neden analizini otomatik olarak yapıyor. Düzeltici faaliyet ve telafi edici faaliyet öneriyor. Kapsamlı raporlama ve veri görselleştirme. Burada da web ortamında tablet ve mobil cihazlar tabanında bilgileri görselleştirme ve üst yönetime sunma var. Proses optimizasyonu içerisinde. Kimler kullanıyor böyle bir sistemi? Bir çelik testinin üst yönetimi kullanıyor. Bu anahtar performans indikatörlerini izlemek için. Ar-Ge departmanı yeni ürünlerin geliştirilmesine kullanıyor bu data mining opsiyonlarını. Metalürjistler kullanıyor. Günlük işletme mühendisleri, kalite kontrol mühendisleri ve günlük kalite operatörleri böyle bir sistemi aktif olarak kullanıyorlar. Böyle bir sistem Türkiye'de Tosyalı Demir Çelik İskenderun Sarısaki testinde olacak. Onların da böyle bir tesisi var. Türkiye'de de olduğundan dolayı sevinçliyiz. Böyle bir sistemin yararları neler? Böyle bir sistemin yararı ulaşılabilecek bir kalite kusurunun tesisin içerisinde yakalanması ve müşteriye gitmemesi. Olası bir kalite kusurunun şirket içerisinde yakalanması müşteriye gitmesinden ziyade 30 kat daha ucuz maliyetli oluyor. Ve bu şikayetlerin azaltılarak şirketin ciddi bir tasarruf sağlıyor çelik üreticileri. Ve fabrika içi kalite divertleri de azaltılıyor. Çünkü tesis içerisinde oluşan kalite sorunlarının kök nedenleri bulunup ve kökünden bertaraf edildiği takdirde şirketlerin iç kalite oranları da yükseliyor. Ve tüm proses ve kalite verileri için merkezi bir veri tabanı var böyle bir sistemin ve sistematik veri analitiğine temel sağlıyor. Bu toplanan verilerle veri analitiği yapılıyor. Tamamen şeffaf ve izlenebilir, kolay erişimi olan bir sistem. Galvaniz hattından çelikhaneye kadar ürünü hızlı bir şekilde saniyeler içerisinde bütün geçmişini takip edebiliyoruz. Çok önemli bir hususu var proses optimizasyonunun çelik üreticiler için, özellikle otomotiv sektörüne ürün üretmek isteyenler için. Otomotiv kalite sertifikalandırmasında tam destek sağlıyor bu sistemler. Çünkü otomotiv üreticilerinin çok sıkı denetim mekanizmaları var ve genellikle üretim esnasındaki kalite uygunsuzlarına dair hangi alarm sistemleri olduklarını çelik üreticilerine soruyorlar. Hangi kök neden analizlerini yaptıklarını, hangi düzeltici ve önleyici faaliyetler aldıklarını çok sıkı bir şekilde takip ediyorlar. Böyle bir sistem bütün bu saydığım bilgilerin hepsini kaydediyor ve bunların çıktıları auditörler için yeterli oluyor böyle bir sertifikalandırmadan hızlı bir şekilde geçmek için. Son olarak Asset Life Expert'ten bahsetmek istiyorum. Bu da bir bakım uzmanlığı sistemi. Tesisin kullanılabilirliğini yani net çalışma saatini
Süremizi bayağı bir açtık pardon ama biraz hızlanabilirsek.
Tamam, hemen bitiriyorum. Alex sistemi de bakım uzmanlığı sistemimiz. Normalde geleneksel sistemlerde sadece bir alarm geliyor ve bunu ancak uzman bakım profesyonelleri değerlendirebiliyor. Ama her bakımcı bu seviyede değil. Bu nedenle Alex sistemi bakım teknisyenlerine hazır bilgiler sağlıyor. Gelen örneğin bir pompa alarmı geldi. O pompanın lokasyonuyla ilgili çizimler, yapması gereken ilk faaliyetler neler, ilk neleri kontrol etmek istiyor. Bunları hızlı bir şekilde öneriyor ve bakım şirketlerin duruş sürelerini, plansız duruş sürelerini bakım arıza kaynaklı bunları azaltıyor. Bunun da yararları son slaytımız hızlı ve kolay erişimi olması ve hızlı aksiyonlar almak için akıllı destek vermesi, 7/24 olması ve cazip fayda maliyet oranı. Evet, akıllı çelik tesisinin gereksinimleri ve çözüm önerilerinden bahsetmeye çalıştım. Hepinize teşekkür ediyorum sabırla dinlediğiniz için.
Can Bey teşekkürler. Çok güzel bir sunum oldu. Umarım izleyiciler de keyif almıştır. Evet, sayın katılımcılar, bu şekilde oturumumuzu sonlandırmış bulunuyoruz. Bir bilgi paylaşmak istiyorum. Bu platform bir hafta offline ziyaret edilebilecek ve sunumlar izlenebilecek. Yine bu platform üzerinden ulaşabileceksiniz. Çok hızlı bir şekilde anket sonuçlarını ekrana getirebilir miyiz lütfen? Rica etsem. Evet, oturum başında bir anket planlamıştık arkadaşlar bildiğiniz gibi. Birinci sorumuz dijitalleşme Endüstri 4.0 firmamız için rekabet avantajı sağlayacağını düşünüyor musunuz sorusuna izleyicilerimizin, katılımcılarımızın çoğu evet demiş. İkinci sorumuz firmamızda dijitalleşme Endüstri 4.0 ile ilgili çalışma yapmayı düşünüyor musunuzdu? Buna da yine izleyicilerin çoğu evet tıklamış. Son sorumuz biraz detaydı. Firmanızda dijitalleşme Endüstri 4.0'ı şu ana kadar geçmeyi düşünmemenizin nedenleri nelerdir diye sorduk. Hemen hemen eşit cevaplar var. Bunlardan bir tanesi yeterli bilgi sahibi olmama, firmanızın teknik altyapı yetersizliği, güvenlik ve siber saldırılardı. Hemen hemen her üç cevabı da eşit katılımcılar eşit olarak cevap vermişler. Evet, teşekkür ediyorum. Türkiye, Avrupa ile Asya arasında bir köprü durumunda. Afrika'ya yakın 3 taraflı denizlerle çevrili, uygun iklim özellikleri ve coğrafyasıyla endüstrinin temeli konumunda demir çelik sektörünü geliştirerek, üretimi arttırarak, teknoloji ve endüstri 4.0'ı kullanarak endüstrileşme ve gelişmiş ülkelerle rekabet avantajını sağlayacağını düşünmekteyim. Dolayısıyla bu oturumun herkese faydalı olduğu kanısındayım. Çok kısaca sizlerle etkinliğimizle ilgili birkaç istatistiği de paylaşmak istiyorum. 2 günlük canlı etkinliğimiz sırasında toplam kayıtlı kullanıcı sayımız 1800'ün üzerinde. En son aldığım veriler 1800'ü geçmişti. 23.000 gibi çok güzel bir sayıda tıklanma oranımıza ulaşılmıştır. Salonda aktif dinleyici sayımız 350'nin altına hiç düşmemiştir. Ayrıca 550'nin üzerinde de katılımcımız oturumlarımızda olmuştur. Her standte de yine stand ziyaretçileri için de bu önemli bir fırsat oldu açıkçası. Her standte minimum 600'ün üzerinde ziyaretçi olmuştur. Gördüğünüz gibi Türkiye'de ilkini yaptığımız ve yoğun emek harcadığımız ve başarıyla bitirdiğimiz bu etkinliğimizde emeği geçen tüm arkadaşlar yürekten tebrik ediyorum. Metem yaparsa iyisini yapar. Metem izlemeye ve takip etmeye devam edin lütfen. Ayrıca bu sempozyumda sponsor ve stand açarak destek olan firmalarımıza da sonsuz teşekkürlerimizi sunarız. Siz değerli katılımcılarımıza da, sunum yapanlara da desteklerinden dolayı çok teşekkür ediyorum. Herkese iyi akşamlar diliyorum. Hoşça kalın, bizi sabırla dinlediğiniz için.
Merhabalar kıymetli dostlarım, değerli meslektaşlarım. Hepimizi oldukça derinden etkileyen bir pandemi sürecinin ortasından geçiyoruz hep birlikte. Tüm dünya bir şekilde bu buhrandan ama az ama çok etkilendi ve etkilenmeye de devam ediyor. Elbette bizim sektörümüz olan demir çelik sektörü de bundan nasibini az ya da çok aldı. Tüm bu olumsuzluklara rağmen birbirimize olan hasretimizi bir nebze olsun azaltabilecek bir dijital etkinlikle bir araya gelmeyi hedefledik. İçinde işletmelerimizin Covid'le nasıl mücadele ettiğinden başlayarak sürdürülebilir ve daha az karbon salınım odaklı bir endüstri olmak için neler yapmamız gerektiğine kadar birbirinden çok değerli konu ve konuşmacılarımızla bir araya geliyoruz. Katılımın tamamen ilgi duyan herkese açık olduğu ISS Digital etkinliğimizde buluşalım. Görüşmek üzere.